All right. I think we're live. Mic check 1 2 1 2. Mic check 1 2 1 2. If anyone in the chat can hear me, just push 1. All right, got a confirmation from the chat. Thank you for the confirmation. Welcome back to the Black Brain Trust. This is episode 508, Black Blockchain Talk. Please hit the like button as you come in, share the video if possible, hit that notification bell so you get all the updates from the Black Brain Trust, including those posted on the community tab. Document and description beneath the video for you to follow along with. If you want to engage in the discussion, there'll be a link in the chat for you to click on. When you click on the link, make sure you raise your hand so that one of us can acknowledge you and advance you to the panel. Before you join the panel, make sure you update your Zoom client so that you have the latest Zoom client so that you ensure that you have full compatibility with the discussion tonight. Let me give a shout out to people who showed up first in the chat. Zero, peace to you. The Threshold, peace to you as well. Money God Trading, peace to you as well. Front Yard J, good evening to you. Complex Design, good evening to you as well. Yeah, I think we got enough people. We can get started. Yeah, fire this up real quick. Estua, what's going on? No, they didn't exactly kill us. It was somebody who wanted us killed. It was like swatting, only YouTube style. So they came for us. We managed to get out of that situation a couple hours ago.
What up, Mike?
Hey, what's up, man?
Chilling, man.
I'm chilling, man, chilling. All right, let me get to the first item on the docket. This is from NASDAQ. HTC introduces cryptocurrency mining for mobile devices. This is interesting. Let me expand this out. Mobile phone manufacturer HTC has demonstrated a special interest in the blockchain and cryptocurrency space, introducing numerous industry-related features in its flagship Exodus smartphone. Now, it will allow its customers to participate in one of the space's most critical practices by launching an app through which they can directly mine cryptocurrencies. This should be very interesting. Launched last year, HTC Exodus 1S was the first ever smartphone with the ability to run a full Bitcoin node, allowing users to directly validate transactions on the network's 270 plus gigabyte blockchain. This built on progress HTC had already made in allowing its products users to store their private keys needed to access and protect cryptocurrencies. With the Exodus 1, we gave people the power to own their own keys. Now we're giving people the power to run their own node. Phil Chen, HTC's decentralized chief officer, told Bitcoin Magazine. As the company was preparing to launch the phone, it's about building technology for the free world. As may be expected for such a challenging technical addition, the Exodus's full node capabilities left some functionalities to be desired upon its introduction. However, it still represented significant progress in bringing a vital piece of the blockchain sector into the hands of more people, in a clear signal that HTC sees the strategy as part of its future. As its next step in integrating its devices with the cornerstone practices of the cryptocurrency world, HTC has denounced has announced D-Miner, an app developed by Midas Lab that is expected to allow users to mine cryptocurrencies when it becomes available sometime in Q2 of 2020, so a couple months from now. Cryptocurrency mining is notoriously energy intensive and therefore expensive a practice. HTC believes it has circumvented that obstacle for mobile users somewhat by focusing its mining functionality on Monero XMR, though users probably won't be able to turn much profit by mining with such relatively low computing power. HTC appears hopeful that they won't lose money and will be introducing new touch points into the space. Midas Labs empowers Exodus 1S user to mine at least 38 cents of XMR per day on average, while the electricity cost is less than 50% of that, Forbes reported. Part of the reason for the endeavor is to deepen the process of decentralization by providing hardware-related solutions for the mobile industry. This decentralization appears to be a key driving force behind HTC's interest in this space. At HTC, our position is to use our mobile phone to drive further decentralization, Chen told Forbes. The mobile phone has become the primary computer device for of the people, and making it accessible to everyone empowers the people. It is clear that the loftier goals of decentralizing the cryptocurrency mining industry and taking a step to make the practice mobile will be more motivating for users than any potential for significant profit through the new app. Even if you mine every single day, that 38 cents estimate would yield $1.39 of XMR in a full year per decrypt. For context, the most recent edition of the Exodus 1, the Binance edition, cost around $700. Assuming the price of the Monero remains constant, it would take a half a millennium of mining to get your money back, and that doesn't factor in electricity costs. Still, a lack of immediate profitability or even effective mining capabilities should not stand in the way of HTC bringing more of the cryptocurrency world to a wider audience through this new launch. So I get what they're saying, the criticism of it, and I wholeheartedly agree with it. It would take you a long time to actually recoup the money off it, but phones don't usually maintain their value anyways. So using that as a justification, I don't think it's fair. But I think what could happen, I mean, and they're just exploiting the CPU power of the phone itself. I think what could happen is if someone comes up with a docking station, whether it's HTC or somebody else, the docking station could turn into another form of computing power. So in other words, the docking station itself would have a CPU in it. So at night when you charge your phone, you dock it and then it connects to the phone and synchronizes the system on chip, the SoC, to the docking station that has another SoC in it, possibly, and would leverage the CPU, the computing power between the docking station and the phone itself, and that would enable more processing power. Not saying it's the best solution, but it is a start. And I think that there is a lot of, a lot of good opportunity can come out of mobile computing power. This is just the beginning. We don't know what's coming down the pike. So,
well, I was gonna say, Mike, I think because that's the position I'm looking at it. I think more than anything, we're looking at a use case, right? More than anything. But if I were to garner into the future, because when we do the follow-up micro transport, I'm actually going to go into a blockchain node network that's based on transportation that I'm looking into right now. So it's actually kind of apropos. And I think it largely just has to do more with a use case at this point. Like you said, this is just kind of like the start. I think once you see the viability in it, then what you're going to see is specific uses right? Where now it's going to be a thing, right? And I even want to say that when we do the micro transport, one of the things I'm going to talk about might actually fall into another use case scenario for what we're talking about, because it requires your phone. It requires the use of your phone and geotag. It basically geotag locations. So it's going to basically it's crypto mining through movement, basically. But we'll talk about that more. But it requires your phone.
Right. Right. And I think, like the article says, for a lot of people, their phone is their only real device. They don't have multiple devices. Like when I was in Africa, most people don't have laptops unless they're in school. And so their phone is their smartphone is their go-to device for 99% of what they want to do, pay bills or buy things online and use the internet and so on and so forth. That is their primary device.
Smartphone. So I'm sorry. Go ahead, Mike. I'm sorry.
Yeah, that is their primary device. And so what happens here is we have to think out, we have to stop thinking from a first world perspective and from a third world perspective and a developing country perspective. Because when you design apps, when you become an IT professional or whatever, a coder or whatever you want to call yourself, you have to think, what is the lowest form of computing power that's available, and how do I ensure that my app is cross economically compatible, socioeconomically compatible?
Literally, that's going to be a smartphone.
Yes, right. But smart TVs, right? We have to think about people don't have access to just, MacBooks. I mean, people in college in Africa had MacBooks and stuff, but most people.
You're actually right, dude. We covered that actually some time ago. You brought that up as a subject or a topic, was using smart TVs.
Yeah. Most people don't have these lavish, half-eaten apples on the back of their devices. They have an Android device or they have a Chromebook at best now, and so that becomes their world. And so we have to, when you want to get into IT, you want to get into the application development side, cloud development side, you have to think, what is the lowest common denominator from a technological standpoint, socioeconomically speaking? How do we reach that underserved demographic from a technological perspective? You can't just say, well, this is designed for Apple, an iPhone 8S or something like that. Yeah, that sounds cool, but most of the people I talked to over there, if they did have an iPhone, that thing was cracked up, or it was a very old iPhone. It was the last iPhone that they could have.
Hey, Mike, do you remember back maybe late 2018 where we were trying to do that, the smart device deal in Nigeria? And that's really what that was about. It was about getting quality refurb and secondhand iPhones and shit like that there, because of what you just said. Like they're getting like the eBay special.
Well, somebody,
you know what I mean?
Somebody traded in at a store or something like that, and that was the deal, right? They got it. Somebody imported the phone. The phone wasn't sold over there. When I was over in Joburg and at the Vodafone store, there was no iPhones there. There was HTC and Huawei and OnePlus. They had the Android full scale lineup from end to end. And so when you have a phone that can do crypto mining, it sounds minuscule now, but when you really think about how exploitive a chain of phones could be, right? Then you start to say, oh, this makes a lot of sense, because the computing power has now been aggregated across multiple devices. And so those are the type of concepts and scenarios that I want people to really, who want to get into IT, that's how you have to think. What is the technological, socioeconomic impact that this is going to have?
All right, hey, Mike. So, Mike, I'm gonna put this out there. So, for people who are listening, and for anyone who can't, throw this in the chat. So, I'm gonna give you guys a little bit of homework leading up to the micro transport follow-up hangout we're gonna do. Look up XYO networks. Okay. It literally what Mike just said. That's the ticket.
Yeah.
Literally what he just said. Literally, dude. Look that up, XYO networks, and we're going to talk more about it.
All right, next item on the docket is from cointelegraph.com. Interchain data hosting project combines edge computing with DLT. We kind of went over this, I think a couple weeks ago, if not more. Interchain decentralized data hosting project Bluezell announced the launch of its mainnet, which aims to combine the advantages of edge computing with distributed ledger technology. According to an announcement shared with Cointelegraph on April 9th, Bluezell will host a network stress test dubbed Swarm of Duty, which will be incentivized with $30,000 worth of tokens for developers, token holders, and validators. The company says that this test is the last step before Bluezell's mainnet launches and is meant to ensure that the network can manage real-world usage. Bluezell's team claims that its technology enables decentralized application dApps on any blockchains to store and access its data in a secure and distributed manner. According to the announcement, this prevents the dApps reliance on centralized data storage infrastructure, which could serve as a central point of failure. The network divides its nodes into groups that it calls swarms, which can be based on geographical position, function, and even application. This reportedly allows the network to enjoy some of the bandwidth and latency advantages typical of edge computing systems. Edge computing is a variation of cloud computing that has servers scattered across the globe in order to connect users to servers near them instead of one centralized server. Bluezell CEO and co-founder Pavel Baines explained. A swarm is a collection of nodes all working together for consensus. This means that we don't require system-wide consensus. So we can have a swarm that does validation for Asia. Let's say there are 30 nodes in that swarm. Let's say traffic builds up and we decide, let's have a swarm just for Japan. We can launch that easily. The advantage we get is ensuring fast speeds and transactions and scalability. Baines told Cointelegraph that he believes this approach results in advantages over competitors such as IPFS. With members, let me advance it real quick. With members of the public going to being able to run edge replica nodes that can serve out Bluezell's service requests, all the advantages of edge computing can be met. In fact, with the success of Bluezell's crypto economic system, Bluezell will be able to bring edge computing far closer to the consumer than any traditional edge computing system has been capable of. Bluezell states that a recent consensus engine update made it the first database to use the inter-blockchain system Cosmos, Atom, and its Tendermint consensus protocol. Baines told Cointelegraph that using the technology brings the network scalability advantages, proof of stake, support of interoperability with other blockchains. Baines explained that crypto economic incentives ensure data availability. Customers pay transaction fees when taking advantage of data storage, making changes to the data motivates validators to perform network maintenance. Blockchain reliability and censorship resistance are values that many try to carry over to other industries. As Cointelegraph reported in a January use case analysis, one such industry is the data storage space, where some are trying to create solutions that can safekeep data while taking advantage of the features of the blockchain. However, many blockchain-enabled data storage solutions offer security, but leave the data transparent and accessible to anyone. This is true. From an infrastructure standpoint, you do have these issues. We just saw a breach, I think this morning or yesterday, where some data was actually pulled because it was not data, but the code was actually AI code was left unsecure on a database. Very.
Who?
I forget the company now.
Okay.
The company now, but yeah. Here's my thing on edge computing and DLT. I think that the cost of computing is going to come down so much, and at the end, the crypto economic incentives, like this is pointing out. I think people who can afford to run a mini edge or nano edge, I should say, nano edge. So like an Xbox PS4 console size edge computer that broadcasts out to the public and becomes a part of this consensus network. I think that's going to be the way to go in the future, maybe about 7 years from now, maybe 5 years from now at best. I think you'll start to see more of that. That device might be expensive, but it also turns more money, or they'll be able to convert, in a white box sort of edge computer, nano edge computer, to be a part of that consensus network in order to bring more computing power to the edge and processing power to the edge for all these IoT devices coming online, because this is a part of the infrastructure. But if people,
what about Arduinos?
No, the Arduino is a controller. It's not the actual.
I mean, not a whatchamacallit, a Raspberry Pi.
That might be too slow for Edge. Mm-hmm. So Edge is a total system, but it's not just a processor. So for Edge, you're talking about a box designed from the ground up to be what it is.
Like a server almost.
Yeah, it's like a mini server.
Right.
Okay. It's a mini. Well, it's a application specific server. It's an application specific server. But I think with the way technology is moving, that it's going to be miniaturized down. So now you don't have to worry about this big box, the size of an LS1 engine or something like that. It'll probably be the size of like an Xbox 360. Mm-hmm. But people's homes will become more a part of the edge, right? You'll have this massive edge network and roll.
I think do you think they'll even be sort of like, well, even maybe like a revenue model in that?
Yes, that's crypto economic incentives, right?
Right.
Right. Yep. And then you factor in 5G. Someone has a 5G controller on their, or antenna on their house. What's to say that they can't do something with that? Because 5G is going to be ubiquitous no matter what. All these people who are afraid of 5G, it doesn't matter which about 5G. It's coming.
You might as well set up a fucking node, right?
Right.
I think you're going to be interested when we talk about XYO networks, the microtransport live stream. Mm-hmm. Live stream, that's right, live stream. I think you're going to be pretty interested in some of that, because a lot of what you've covered so far, man, is right in line with that.
Yeah, this is the future of computing, man.
Yeah, man.
Absolutely.
Big bro.
Hey, what's going on, dude?
What's going on, Mike? What's going on?
Sure, man. Let me get the next item on the docket. This one is from venturebeat.com. 4 things you need to understand about edge computing. This is going to be somewhat of a primer. Edge computing has claimed a spot in the technology zeitgeist as one of the topics that signals novelty in cutting-edge thinking. For a few years now, it has been assumed that this way of doing computing is one way or another the future. But until recently, the discussion has been mostly hypothetical because the infrastructure required to support edge computing has not been available. That is now changing as a variety of edge computing resources, from micro data centers to specialized processors to necessary software abstractions, are making their way into the hands of application developers, entrepreneurs, and large enterprises. We can now look beyond the theoretical when answering questions about edge computing usefulness and implications. So what does the real world evidence tell us about the trend or this trend? In particular, is the hype around edge computing deserved or is it misplaced? Number one, edge computing isn't just about latency. Edge computing is a paradigm that brings computation and data storage closer to where it is needed. It stands in contrast to the additional cloud computing model in which computation is centralized in a handful of hyperscale data centers. For the purposes of this article, the edge can be anywhere that is closer to the end user or the device that is than a traditional cloud data center. It could be 100 miles away or 1 mile away on premises or on device. Whatever the approach, the traditional edge computing narrative has emphasized that the power of the edge is to minimize latency, either to improve the user experience or enable new latency sensitive applications. This does edge computing a disservice. While latency mitigation is an important use case, it is probably not the most valuable one. Another use case for the edge computing is to minimize network traffic going to and from the cloud, or what some are calling cloud offload. And this will probably deliver at least as much economic value as latency mitigation. The underlying driver of cloud offload is immense growth of the amount of data being generated, be it by users, devices, or sensors. Fundamentally, the edge is a data problem. Chetan Venkatech, CEO of Macrometa, a startup tackling data challenges in edge computing, told me late last year, cloud offload has arisen because it costs money to move all of this data, and many would rather not move it to if they don't have to. Edge computing provides a way to extract value from data where it is generated, never moving it beyond the edge. If necessary, the data can be pruned down to a subset that is more economical to send to the cloud for storage or further analysis. So this is very true. Think about Amazon's fulfillment centers, right? Amazon's fulfillment centers would be the data center or the cloud, while they're I don't even know what you call those places that they I forget the name of it. It's a special term for those
What, they're vendors?
No, Amazon has a special way. Amazon has a distribution center, then they have a fulfillment center, and then there's another.
Are you talking about FBA, fulfillment by Amazon?
Yeah. So there's that last mile.
Yeah, FBA.
So what happens with Edge is that Edge sits very closer to the street than it does to the cloud itself. And so what's happening here is that the argument is that it's because of latency, and to an extent, latency does play a significant role, but it's more about processing that data and not moving it all the way to the cloud, because moving it to the cloud, does take a long time, but it's about the cost per transition. You don't want that data to be in transit all the way to the cloud if you can actually process it closer to the street or to the edge or where the device is going to be at or where the person is going to be at. And that's what I was saying earlier in the last article, that at some point, I think people's houses will become edge-like sort of facilities.
Nodes.
Yeah, everybody's house will actually participate in some form of edge computing. At some point, I suspect that will be the case. I hope I can be the driver behind that. A very typical use for cloud offload to process video or audio data, two of the most bandwidth-hungry data types. A retailer in Asia with 10,000 locations is processing both, using edge computing for video surveillance and in-store language translation services, according to a contact I spoke to recently who was involved in the deployment. But there are other sources of data that are similarly expensive to transmit to the cloud. According to another contact, a large IT software vendor is analyzing real-time data from its customers on premises IT infrastructure to preempt problems and optimize performance. It uses edge computing to avoid backhauling all of this data to AWS. Industrial equipment also generates an immense amount of data and is prime candidate for cloud offload. So is autonomous vehicles. 10 years from now, those tractor trailers, those autonomous tractor trailers, all those cars that's going to come out there, those drones, all of those things generate data. And so,
Mike, that's purely theoretical at this point.
Oh yeah, we don't want to send all of that device data, the autonomous vehicle, the tractor trailer, the drones. You don't want to send all that data up to the cloud. You want to send it as close as possible to the edge, and that edge is going to process all that data and then do what it needs to do, and then the final processing time would be all the way, at the cloud. The cloud won't get it until it's already finished, and by the time you figure out what's going on, you won't even know that there was an edge there to begin with. You just know that it happened really, really quickly. YouTube will be another player in all of this, especially Google for that matter, because everybody wants to stream video, everybody wants to live stream 3.0. So what's going to happen here is that data needs to be, that video, that audio needs to be stored somewhere. If you're going to be live streaming, well, you can't wait for that stuff to go all the way back to California. That stuff has to be happening right here locally.
It's almost like you're going to have like your, where they have like your, what do they call your syndication networks?
Mm-hmm.
Right? Like how they have like there's NBC, right? Mm-hmm. And then there's affiliates in all of these areas. Right. So that now those are going to be like nodes in a sense.
Mm-hmm.
Right. So because you always want to be able to broadcast live breaking news. I'm sorry, that word live, but you'll want to be able to accommodate all of the data traffic and the data transfer that's happening in these central areas. And then you could disperse it out more evenly. It's like load balancing.
Yeah, to an extent. And the person who knows about infrastructure a thing or two, Zero is on here. What's going on, Zero?
What's up, you nerd?
Hey, what's up? What's up, Complex? Sorry, I got my kid is watching TV. I just had to hop on because you guys are talking like right up my alley here. But we do this like right now, especially what you guys are talking about right now with the with edge caching.
Mm-hmm.
Yeah, what you're talking about is
what's up, Zero? What's going on, man?
Oh, what's up, Nagon?
What's going on, baby?
Not much, man. Just chilling with my clone.
Okay.
You are a clone. All right, so
do I fix houses?
No, you don't.
Hey, so what do you call a Boba Fett?
Yeah. So sometimes I call them white me.
Oh man. I know where that's going. Go ahead.
All right, hold on. Have a seat, we'll do. All right, so as far as like the edge caching stuff goes, so we do that now where it's an extension of like deduplication, where you hold on to often used data and just put it as close to the edge as possible, like a Cisco router, and it would hold anything that's literally always used all the time, like printer data, images, anything it can grab from the web. Netflix does this. And it's also an offshoot of what CPU manufacturers started doing this first.
Yep.
Intel used to take often used instructions that are always used most of the time, like 60% of the time, and just throw it right into the first layer of cache.
L1.
L1, so you can just speed up processing. That's why we get these ridiculous gigahertz speeds, because without that, you would start having problems with quantum physics where your processor wouldn't work. So anyway, yeah, with the edge caching, I don't want to get too far in the weeds, but it's exactly what you guys are talking about, and it's an extension of. No, you guys can call it edge caching. You call it what now?
What are you talking about?
Edge computing.
Okay, it's an extension of edge caching. So so it's basically a magic trick that speeds everything up. So you get less latency because you're not pulling things that you don't have to, basically. So it's really smart. This is what's going to actually help 5G with so self-driving cars have those maps built in and stuff.
Yep.
But let's just say there's like a traffic accident, and for the car to update, it doesn't hold stuff that's already there. It's always going to be there. But then when a traffic accident happens, there's going to be data, traffic related data that's like often. So like they'll have, you know, a computer will be like an actuary and calculate how many times the accidents happen, how all of this data, basically the machine learning puts all that stuff as close to the edge as possible. And that'll allow like a self-driving car to update at almost zero delay. And then it'll enable the infrastructure to work better.
Is zero like the you have to maybe kind of dig back in the archives of maybe some of the earlier live streams that we did on micro transport, where I showed there's the phone app, and then there's basically the laptop software, and then the third component is sort of like the admin or mechanic app. But it's the laptop software that really kind of does sort of like that edge roll. And I actually showed it, but it basically records like everything you just said, like even like scooters, dude. If it's broken, if something's happened where it's not working, then it basically generates an auto trouble ticket.
Okay.
You know? Yeah, through IoT.
It's an application-based system, but yeah, but to Zero's point, for those of you who don't know what he's talking about, in Cisco routing and switching, there's something called BGP, which is Border Gateway Protocol. And what you do with BGP is that you would actually map out the closest, the devices closest to the network to get the fastest timing and the fastest offload and stuff like that. When you get into network engineering and infrastructure development or infrastructure engineering, that's where your CCNA, CCNP and stuff like that comes in handy, because that's exactly what you do for for your responsibilities. But they've taken this and brought it to the cloud computing area and from the edge standpoint. So it gets really complicated, but in reality, software defined networks is actually taking care of a lot of this stuff.
Right. Yeah. Exactly. Yeah. And again, it's definitely and all. They basically extended what those processor makers were doing, which is pretty smart. I don't know if anyone wants to maybe go research it, or maybe I'll find an article and maybe post it in your comments later. But I mean, if you take a look at what Intel and AMD was doing at first with the layer 1 caching, it's basically that, except applied to a network. Yeah, so yeah, I mean, I guess it just helps people understand it better if they see the origins of it and see how simply they took something so simple and then applied it to like something huge like the internet.
Yeah. Because it's a good point you bring up about CPUs, because CPUs have L1, L2, and L3 caches at one point. So,
no, they still do. They kind of have to.
Well, I think most CPUs nowadays have L1, L2, but before they used to have a big L3. They used to have like a 4 megabit or 2 megabit L3. That thing was massive. But back then, processors were a lot bigger, right? Your Pentium 2s and Pentium 1s. The processors were much bigger. Let me go through this rest of this article. Number 2, the edge is an extension of the cloud. Despite early proclamations that the edge would displace the cloud, it is more accurate to say that the edge expands the reach of the cloud. It will not put a dent in the ongoing trend of workloads migrating to the cloud, but there is a flurry of activity underway to extend the cloud formula on-demand resource availability and abstraction of physical infrastructure to locations increasingly distant from the traditional cloud data centers. Though these edge locations will be managed using tools and approaches evolved from the cloud, and over time, the line between the cloud and the edge will blur. Yeah, this is true. This is very true. I don't know why I don't see it. Don't say something like that. Number 3, edge infrastructure is arriving in phases. While some applications are best run on premises, in many cases, application owners would like to reap the benefit of edge computing without having to support any on-premises footprint. This requires access to new kinds of infrastructure, something that looks a lot like the cloud, but is much more geographically distributed than than a few dozen hyperscale data centers that comprise the cloud today. This kind of infrastructure is just now becoming available and is likely to evolve in 3 phases, which with each phase extending the edge's reached by means of a wider and wider geographic footprint. Yeah. Multi-region and multi-cloud. The first step toward edge computing for a large swath of applications will be something that many might not consider edge computing, but which can be seen as one end of a spectrum that includes all the edge computing approaches. This step is to leverage multiple regions offered by the public cloud providers. For example, AWS has data centers in 22 geographic regions with 4 more announced. An AWS customer serving users in both North America and Europe might run its application in both Northern California region and the Frankfurt region, for instance. Going from one region to multiple regions can drive a big reduction in latency, and for a large set of applications, this will be all that's needed to deliver a good user experience. Yeah, so when we run our applications and we connect to the applications, we do connect people on the East Coast closer to the VA servers or the New York servers on the East Coast, and the same thing for people on the West Coast. We never, when we connect these people to these applications, we never send them all the way to the West Coast or send them all the way to London or something like that. It doesn't make a whole lot of sense. You want to have the fastest response time possible and have the best uptime availability for the user. So that is very important. What is this thing doing? Phase 2 is the regional edge. Just talked about that. Phase 3 is the access edge. The third phase of the edge's evolution drives the edge even further outward to the point where it is just 1 or 2 network hops away from the end user or device. In traditional telecommunication terminology, this is called the access portion of the network. So this type of architecture has been labeled the access edge. The typical form factor of for the access edge is a micro data center, which could range in size from a single rack to roughly that of a semi-trailer, and could be deployed on the side of the road or at the base of a cellular network tower. For example, behind the scenes, innovations in things like power and cooling are enabling higher and higher densities of infrastructure to be deployed in these small footprint data centers. So let me show you a picture of, I think people.
Hey, Mike. Yeah, I'm not sure what's going on, dude, but you're borging a bit, but it's going in and out. So it'll be borging for a minute, then you're good for a few seconds, and then it starts again. So I just want to let you know.
Yeah, I think it's my laptop. Can you hear me?
Yeah, we can hear you.
Yeah, I think it's my laptop. All right, let me just show a picture of the Sun Micro Edge, Sun Micro container computer. So this is what they're referring to right here in the article. I don't know if you all were able to hear me and what I was saying, but this is what they're talking about, taking these shipping containers and actually converting them into these portable drop data centers. I don't know if maybe Zero might be familiar with these. I don't know how old he is. It might be before his time. This is what they're referring to. So this rack has all the computing power. I mean, this storage container has all the computing power in there. And you can basically drop it off a truck in a matter of minutes or as fast as possible. And like the article is saying, it sits under the trees. Well, not the, why did I say under the trees? Under the 5G tower. I don't know why I said tree. Actually, this is a good picture of it right here. So you'll see 1, 2, 3, 4, 5, 6 racks up in there with the servers on there, high performance computing on the edge. This would be an edge-based device.
Yeah, I remember a different use case for those containers a long time ago. There was this company, Bloom Energy. They make these power cells, which is basically greatly reduce the amount of electricity you use and stuff like that.
Didn't they use some sort of like natural gas fusion technology or something like that?
Yep. And then so what they did was they used those cells along with Google having these shipping containers near the ocean because they were using the ocean to cool their to cool their server racks. So they would put the shipping container, they put a bunch of servers in the shipping containers and put them in the water and have the Bloom energy cells as the power for them. It was basically a way for them to try and reduce their electricity bill by like millions of dollars. But this was a long time ago, so the use case for it now is probably different.
Yeah, definitely.
Well, now, I mean, you just may as well just get a power wall.
Well, you have a power container. That's what you'll really have. You have a container that
Power
connects
container. There you go.
that connects to that container where your edge computing is happening. So number 4, the new software is needed to manage the edge. I've outlined above how edge computing describes a variety of architectures and that the edge can be located in many places. However, the ultimate direction of the industry is one of unification toward a world in which the same tools and processes can be used to manage cloud and edge workloads regardless of where the edge resides. This will require the evolution of the software used to deploy, scale, and manage applications in the cloud, which has historically been architect with a single data center in mind. Yeah, there's a lot of open source stuff. If you look up OpenStack, which is probably the most commonly used open source cloud computing and edge computing system to be deployed beyond like the Googles and the AWSs and the Azures. It's free, and you can actually use it if you wanted to build out your own cloud computing space from a private cloud computing standpoint, so private to public, and as well as edge. That they do have an edge solution that's been recently updated or deployed, I think in November or October. But the point of the matter here is that edge computing is going to be necessary when you start talking about distributed ledger technology, and you have to know this stuff at some point in order to take advantage of all of the, these, the ability to manage data, from end to end. Because what's going to happen, this is a security issue as well, because like Zero was saying earlier that you have all these mapping systems in real time being updated. What happens when the bad guys decide that they're going to attack that geospatial system? They can feed bad data to it. They can poison it. They can poison the maps. And what happens here is all your traffic lights and all your civil engineering infrastructure tied into this, and all the vehicles tied into all of this, they're going to get bad data on their end, and it's just not going to work. Traffic lights going to be, going green on both sides, and cars are going to be running into each other and taking the wrong routes because the whole stack has been poisoned. That's where distributed ledger, technology comes in, because we can actually secure that data from point to point and don't have to worry about it being tampered with.
Yeah, I can see that, because DNS poisoning and route poisoning.
Yep.
Yeah.
Yep. The whole stack would be poisoned. The whole edge stack would be poisoned.
Yeah, I would imagine it would work the same way.
Mm-hmm. It's happening now. There's a lot of times when your Google Maps tells you to go a certain way, but somebody on a bicycle it has Google Maps going, and they're going down a bike path, but your car can't go down there.
Right.
You're screwed. You went the wrong way. All right. All right, this is from CoinDesk.com. How edge computing can make us more resilient in a crisis. Edge computing has been heralded as a way to increase access to real-time information and to analyze that information more efficiently. But in this moment of public health crisis, we should recognize a potentially significant opportunity that these technologies offer beyond efficiency, the ability of edge computing to weather massive disruption. To see why, it's worth remembering what edge computing involves. These technologies move computer workloads to the edge of network, shifting the collection processing and storage of data from central locations to individual devices such as cell phones. This is significant because of the massive increase of computing power seen in devices that live away from the center of networks. In 1965, Intel co-founder Gordon Moore famously observed that computing processing doubles every 2 years, while the cost of the processing power housed in the same time period. The effects of Moore's law means our smartphones now have more processing capability than NASA's computers when they sent a man to the moon. This, combined with the associated proliferation of data, enables our devices to get smarter as well as to make select information available to more centralized applications such as Uber or Instacart in a more efficient way. Yeah, we talked about this earlier. What does this mean for emergency situations like the current pandemic? In time of crisis, the systems on which we depend are closely examined. Dangerous tests our preparedness, our ability to improvise, and our capacity to act and think locally. Globalization through technology over the past few decades has led to an unprecedented level of interconnectivity, but with it has come a vast and complex chain of dependencies. The locus of control is unclear and often too far from where the crisis occurs. A shock to the system puts pressure on the supply chain and reveals just how extensive and interwoven these dependencies are. The hidden vulnerabilities are revealed and there is no timely way to respond effectively. In a pandemic like this is very true. Most governments have not adopted cloud computing to the extent that private institutions have, and they're lagging behind, especially the public health sector. They just don't have the computing power available or the infrastructure available to deal, real-time updates and things of that nature that happens during the pandemic. There's no real way for at least the public health institutions now to really deal with who's infected and who could be affected and where did they come from and who's a citizen and who's not, who's a resident, who's not, who's legal, who's not. There's no way for them to really process all this stuff because they don't have the infrastructure in place. And this is where edge computing does come into place and cloud computing does come into play. The spread of the COVID-19 epitomizes the kind of shock. While the virus continues to multiply in waves around the world, the effects are being felt across industries. Consumer-facing businesses like restaurants shut down, leading to millions losing jobs. The effects are rippling through the financial and real estate sectors and beyond. A majority of the workers still employed are forced to work from home, many with children whose schools are also shut down, putting stress on telecom networks and delivery services. Chains of dependencies in our economic, financial, and technological systems were undermined long before the pandemic had spread globally. Things quickly spiraled out of control as everyone scrambled to understand the effects at both micro and macro levels. To deal with a crisis, you need information tools to analyze that information in real time and autonomy to act quickly as well as proactively. Edge computing strengthens the local nodes of a global network by providing them with better quality information at higher speeds, in addition to more independence in the decision-making that affects their own ecosystem. What the fuck is going on? Imagine if every town in every country had access to environmental sensors and location data that, combined with diagnostic data gleaned from other regions, could pinpoint where the next cases had a high probability of community spread. With up-to-date information, reliable communication of likely next steps and best practices, our businesses, families, and essential services would be better to adapt and offset stress on our entire infrastructure. Yeah, we just talked about this. We really don't have this sort of infrastructure in place at all. Go ahead.
Oh, me? Oh, okay. Well, so as far as like the medical industry goes, yeah. People are going to have to be willing to accept a tax hike or something, because medical places and government buildings are notoriously bad at upgrading their infrastructure.
Mhm.
So people, I mean, the public is either going to have to pay for it, and even if the public pays for it, they're going to have to be forced to upgrade it. Especially hospitals, God, they never upgrade. You walk to any hospital and they're probably still running Windows XP and Windows 7.
Yeah, he's right about this. I know a company that has 100,000 computers and 80% of them are still stuck on Windows 7. It just can't get off because there's so many computers that have to be rolled out, and they don't have enough desktop support people to roll them out. They don't have enough human resource and human capital to roll them out.
Not to mention they're really strict with security. Like the HIPAA stuff is just super strict. Not to mention now that the GDPR is in full effect, that people who are foreigners and come to America, their data has to be kept separate and all this other stuff. Hard drives have to be encrypted. In fact, if you have a motherboard with an encryptable, if you have a motherboard where you can put a password on it that'll make it so the CPU won't even work, you got to do that too. I mean, so this is why hospitals are notoriously slow to upgrade, and governments as well. But if you want your medical data to be secure in the future, and you want all of this new technology to work as far with the medical system, there's going to have to be a push by the public to force them to upgrade, and they're probably going to make everybody. They're probably going to tax it on everybody because they're going to have to be. You have to force them. They just don't upgrade.
Yeah, you're right about that. That the bureaucratic red tape in HIPAA actually prevents them from upgrading on the fly like they would have if you're a traditional legacy hospital. But if you're one of these new sort of newly rolled out hospitals, you're probably a lot more ahead of your legacy counterparts because you've adopted something like Athena Health, which is a SaaS-based EMR application and system and infrastructure that goes with it. And so you're already ahead. So you don't really have to change too much. Then you start adopting things like Citrix or what do you call it? VMware, View and things like that. Once you start in building out systems like that, you're way ahead of the competition and the legacy for that matter. So your time to transition is actually a lot faster, but that's expensive. Upfront cost is expensive. Zero knows this because he's the infrastructure guy. So you need a lot of human capital to really roll something like that out. Nothing like that happens overnight.
That's true, but hospitals have a lot of money, and to be honest with you, governments they have money, but the problem with governments and hospitals is that they just don't want to.
Yeah,
and I've seen this with my own eyes. They just don't want to do it. They could contract and have this stuff done right away because I've actually done their routers and switches before, but they just don't want to. It's just that simple.
Yeah, they politicize IT spending.
Yeah,
they really politicize it. That's why a lot of these institutions lack cybersecurity in the first place, because they include cybersecurity as a part of their IT budget when it should be a part of their risk management budget.
That's exactly right. And you see these companies that sit here. I mean, I've even seen it with some large insurance companies and so forth that move slow on this kind of. So it actually happens in the corporate sector. But he's absolutely right about it. And some money, it comes down to dollars and cents. That's what these guys are really breaking this down to, which puts a lot at risk. But they are looking at it from a risk type of spending to type of scenario, and a lot of guys are more on the side of spending less money and actually increasing some of the risk. Which sounds crazy, but that's kind of what's going on.
Yeah, think about if an IT budget is about $5 million for a year, okay, and you spent $3.5 million just on network connectivity and infrastructure. And then you get down to the end user computing, EUC. And you went out and you bought all these laptops, you spent $1 million on laptops and desktops and doodads and iPads and shit. Okay, now you're left down to what? $1.5 million left for for security. That's not enough. A single contract with Mimecast or any of these other vendors That's going to cost you $1 million up front. Who's going to manage it now? Because you only have $500,000 left. You want a top cybersecurity guy, you're going to be paying 150 grand. But you want 24-hour support, you're going to need to hire 2-3 guys in maybe multiple regions. That's going to cost you more than $500,000 that you have left over in your budget. You're pretty much tapped out because you shared your budget with IT. You should be sharing it with compliance and regulatory and risk management.
Like all the stuff comes down to the money. Comes down to the, get it right in the head, Mike.
Yeah. Let me read this last portion. As a complement to the cloud, edge computing provides improved strength and security in local networks around the world. The local infrastructures can relieve the pressure on and provide more visibility into the existing complex dependencies, and in turn make the wider system more dynamic, flexible, and resilient. In a world utilizing edge computing, crisis response can be quicker, more informed, and hopefully more effective. 5 years ago, I argued the applications of this tech would prepare us not just for a crisis, but for a more connected world too. A system like this relies on the participation of everyone, of all races in all corners of the world, for the most optimal and efficient global network. It is not only about the algorithm, it's about the algorithm collectively allows us in our hearts and minds to do, while many people have discussed the way forward as a trade-off between efficiency and resiliency. I believe we do not have to choose thanks to the new technologies. I wholeheartedly agree with this. I have no qualms about what this person wrote in this article. I think they're doing a heck of a job articulating these points. Like I said, when this pandemic turned out, we saw the weaknesses and the chinks in the armor of a first world country, like the United States, you know, for all of the ideas of being superior, we were not superior when it came to this. We got caught with our pants down, and many people suffered because of it. Lack of infrastructure and things like that. Even something as robust as a clinic in a lot of predominantly Black and brown areas, they lacked it. You know, they did not have that sort of infrastructure in place, and so they paid the price for it. And now we're starting to see people work remotely, networks tax, people not working, sitting at home on X Hamster and X Vids or whatever they are, you know, not having much to do, killing the bandwidth, killing the networks. All right, last item on the docket is from GCN.com, building a blockchain to verify COVID-19 data. The World Health Organization, in partnership with tech giants, government agencies, and international health organizations, is building a blockchain-based control and communication system that aims to quickly and more precisely detect COVID-19 carriers and infection hotspots. Announced March 27, MPASA promises to securely share previously siloed health and location information between individual state authorities and health institutions such as hospitals and HMOs. Major partners include IBM, Oracle, Microsoft, and Hakera, I guess that's how you pronounce it, Hakera, an enterprise-level blockchain-powered platform provider, which recently launched a data analytics platform to combat inaccurate COVID-19 data. According to IBM's announcement of the project, MIPASA is designed to solve one of the main problems facing clinicians, scientists, and researchers: the lack of integration of verified data sources that can be used with confidence. MIPASA uses the IBM blockchain platform and IBM Cloud to make data analytics and privacy tools more openly available on a Hyperledger platform and deliver an integrated source of verified cases. Users will be able to synthesize data sources, addressing their errors and inconsistencies, and seamlessly integrate credible new feeds according to the company. Public health officials and individuals could upload data about the time and exact location of different infections. The data would be stripped of personally identifying information, but could be used to calculate exposure risk, helping hospitals prioritize resources and letting individuals know whether it's really critical for them to get a test, IBM said. Vipasa validates the data by reconciling disparate data sources such as figures from WHO, the Centers for Disease Control and Prevention, and others in ensuring new data matches the original. It also encourages validation comes by individuals who can report inconsistencies or bad data. The major benefit of using blockchain-enabled platform is that it provides verifiable data because the distribution ledger technology allows for multiple parties to collaborate over the validity of rapidly updating data. Jerry Cuomo, the vice president of IBM Blockchain, told Cointelegraph. To further lock down security, MIPASA is using privacy and cryptography modules that have been implemented by the world's top applied cryptographers and are currently in production and certified mission critical systems that the project's website states. MIPASA is soliciting individuals and organizations to help with development of the platform along with data warriors to report data sources. I don't know why this wasn't established for, these HIV cases and, STD cases and stuff like that. They should have already had a system in place like this a long time ago, at least 10 years ago, back in 2008. They should have had a system like this. But I want to go to, let's go to Hyperledger, because this is what they're referring to, Hyperledger. Fabric. So they use Hyperledger Fabric because IBM, this is IBM's baby right here for blockchain. And so for those of you who don't know, Hyperledger Fabric is IBM's spin of distributed ledger technology, not exactly blockchain, but it's blockchain is the branding name associated with Bitcoin, but this is the distributed ledger technology that IBM uses, which is Fabric. If you go back to our community tab, we posted this back in March. Linux Foundation, who also partners in on this with IBM, posted all of their discounts on blockchain certifications and training, which are very critical sources of training and certification. Nobody that I know has the certification because it's brand new. It just came out. So these things are necessary if you want to get into big companies like IBM and Oracle and Microsoft and whatnot at that blockchain level. This is where the big boys play, in my opinion. Let me read this caption real quick. Hyperledger Fabric is intended as a foundation for developing applications or solutions with modular architecture. Hyperledger Fabric allows components such as consensus and membership services to be plug and play. Its modular and versatile design satisfies a broad range of industry use cases. It offers a unique approach to consensus that enables performance at scale while preserving privacy. So this is the article that this is pointing back to the article we actually just read. What was I going to do? I was going to go to the oh, they don't have it listed here. Anyways, let's get the code. Yeah, so 2.1 is actually the latest. Yeah, 2.1. So what's new? Let's check out what's new in 2.1. Yeah, for whatever reason they didn't update it. Okay, All right, so what's new in 2.1 is add endorser metric for simulation failure. Added metric endorser proposal simulation failures, limit concurrent requests to endorser and deliver services. Allow pair to override implicit collection dissemination properties. Support collection level endorsement policies for discovery. Discover CLI now supports SEC1 formatted private keys. So it sounds like they fixed a couple of things, or at least they added a feature that actually fixes some concerns that people must have had in the past. But at least they're keeping this up, which is very important in blockchain development, because if you if a project forks or goes through what they call a hard fork, you're kind of screwed. You don't want to build your project on something like that gets hard forked. Zero, you had something you want to add?
Oh, no, I was just listening, but I did want to add, as far as when you asked why didn't hospitals employ, or why didn't businesses employ that particular blockchain? Because it's like I said before, you got to force them.
Yeah.
Those industries, I mean, I'm pretty, Nagon, you work with placing people, right?
Yeah, and they're going to recruit.
Okay.
Yeah. Absolutely. Yeah.
Yeah.
So,
You ever had someone go into a network closet and tell you how like in a medical building and just, the horror show that's in there, or you walk into their server room and they don't even have adequate power or anything like that?
and how archaic things are, of course. Yeah.
So that's the reason.
Absolutely. Yeah. We talked about that. We agree with that. A lot of them are slow to move. A lot of them are looking at their bottom line. They figure, hey, listen, if this thing still works, we can go with it. You're saying a lot of these places have workstations and stuff that are still on Windows 7, that are still on Advanced 7.
Yeah.
Man.
So and then their infrastructure might not even be able to support blockchain.
That's exactly correct, because they got upgraded and they got to do other kind of migrations and so forth, which costs money.
Yeah.
These things cost money. They cost money. So I remember when Ally Bank was going from, they were doing Oracle 9, and I think they were upgrading to Oracle 12, and they were doing that migration there. And they had moved down to Charlotte. That migration alone was about $3-4 million just to do that, and the staffing and all that, and that was over a relatively short period of time, and that they would consider that to be a awful lot of money, and that was a big problem for them. But yet, they did it. So, and that didn't seem to me to be that much money, but they were hemming and hawing about it. I was putting some Oracle developers there at the time. So, I didn't think that was a big deal, but
in my experience, most companies view IT as an expense. I actually did a stream about that, where I was basically telling the younger kids, when they get into the industry, they're, everything they do is going to be looked at as an expense. But then at the same time, you'll have old guard things like, for instance, we used to have these financial people that would do 15 minutes of accounting work during payroll, but they would travel to all of the branches, and it was ridiculous, because they're spending a grip of company money, staying at 5-star hotels and just blowing money at 5-star restaurants all week. We're doing 15 minutes of work, and we had these three. Well, at my previous job, we had branches at 3 Hawaii islands, and everyone would fight to go, and they got pissed at me. I ended up leaving like 2 years later, but they got pissed at me because I wrote up a report saying we're wasting like hundreds of thousands of dollars per year when you guys could be upgrading your stuff, so you don't, and you can afford to send them there without it hurting your pockets. So I'm like, if you stop sending them there this year, just this year, and spend that money, redirect that money to IT, so we can get a good backup system, because they didn't have a good backup system. And like, you lose your data, you're gonna lose your company, and no one's gonna have a job. So they did that, but everybody got pissed at me because some financial people couldn't go travel and spend hundreds of thousands of dollars.
That's exactly what you got to deal with, the politics of the bullshit, and everybody wants these gold-plated little trips and hang out. and you're getting in the way of that. You're getting in the way of
Yeah.
of their ease of their ease and fun time. And folks get mad at that kind of thing, you know, which we see a lot of waste, and that just goes on. That goes on in so many different companies. But you're hitting it on the head. Yeah, they didn't like you for that, man. No,
Right, but this is why, like doing important things, like securing that data and using new technologies like blockchain to do things like unmodifiable verification and stuff like that. It's so hard to get it implemented, even though like it'll actually save you from lawyers coming into your building giving you audit lawsuits and shit, because people just want to keep doing the same shit they've been doing for years. But that's why. I mean, it's just human. I'm better than you shit gets in the way of real progress, and people actually having like the job saved behind it, and the company actually succeeding behind it. But that's why.
Yeah, it's milk and honey in those companies, and they don't want to give that up. But they pay the price later, though. You know, look at Palo Alto. I think they spend $1.50 for every dollar they earn on advertising.
Wow.
I mean, imagine that, man. You're not making any profit. I don't know how they stay alive, but you know that's how they run their business.
Yeah, I got a story, like the worst story in the world. I used to work for this company, and they were a distributor, and they had this old sand by EMC. And EMC basically got bought by Dell, and then Dell was like, we're gonna close this and open something else. So they kept the old EMC even though it was out of support. And I kept writing reports every week saying, hey, I showed them a trend line saying when we're gonna run out of space and all of that. And I was like, okay, so they have this AS400, which is a really old Unix system that does their finance stuff.
Yep.
I'm like, okay, when you run out of space, the AS400 is not going to be able to count your money. And if it can't count your money, you're going to start losing like $6 million an hour. And I kept chirping this for like a good year. Me and my colleague, we're sending trend reports every month. Now they didn't do it, and they ran out of space. Once the sand ran out of space, the AS400 choked. They lost $6 million an hour. And right after that, they gave us all the money we needed to build a new infrastructure. But at the very end, somebody walked in and was like, oh no, we don't need all of that. So let's scale back a little bit. They scaled back a little bit. In the very next year, we had an issue with calculating because they didn't get the processor that we needed. Well, no, they didn't. So we needed so Xeons have like they're dual core, but they have like a crazy amount of like cores. Like it's dual socket, but like 20 cores per socket.
Okay.
So they skimped on that, and then we had to implement this this machine that was basically a calculator. It did BI, business intelligence, just did all these analytics for the company. But you need a calculator for that, and you need a strong calculator for that. So because they skimped on the processor, the BI processes used to take like over 2 hours to process, so the data never came out right. And then that cost them because they skimped on and this was after a catastrophe. So that's the shit you got to deal with when you work with companies where they just don't want to do the right thing. And I'll never be able to understand it. But that's what gets in the way of all of this stuff.
Yeah. Yeah, I used to work for Dell EMC, so I was there for the merger. So I can tell you firsthand, there's a lot of companies that were SOL when they didn't upgrade, so when they should have. And they paid the price for it. But in terms of blockchain, I was speaking more to the, to local and state governments, not really adopting the technology when they should have, and paying.
Oh no, sorry. I was saying all that to say you have to force them. That was really my main point. You got to force them. Like the government, they have to be forced. Everybody else, they have to be forced. You got to force them. There's no other way around it.
Yeah. So because Nagone does recruiting, he can tell you that there's a lot of banks sitting on legacy applications built with COBOL and other sort of old languages that no one has been deprecated for years.
Old legacy stuff, and they are afraid to move away from it. They're afraid. They are actually afraid to move away from it. They got some front end stuff lined up all on it, but they ain't trying to move that COBOL, that back end. They ain't not trying to use those big data storage systems out. They are not trying to do it. And we're talking about 2020, my friend. Here we are, and that shit is still there.
And
some
that's,
banks wouldn't believe, and some very big insurance companies as well.
yeah,
They ain't moving out with this stuff.
yeah, and that's why you see a lot of the rise of the fintechs, these neo banks, these new banking companies that don't have brick and mortar space. They operate in the cloud. They don't have to worry about big legacy classic infrastructure, data centers and stuff like that. Everything's in the cloud. Everybody works from home for all intents and purposes.
Well, a lot of banks, they feel it's safer. Some people still, they say the cloud. People worry about the cloud. They think the cloud is not quite as kept. They don't think the cloud is as safe as some of this other stuff that they have locked into these big data storage systems. They have all kind of philosophies as to why they want to keep it there, and there's, of course, there's going to be a big dollar cost to that as well to move off of that. But they are very reluctant to move. And quite frankly, I don't see where this stuff is going. This stuff may be around in 20 years, believe it or not. I swear to God, I really think so. As crazy as it sounds, I suspect this stuff might be. I'm not trying to be funny either.
You mean legacy infrastructure?
That's exactly correct.
Yeah, to an extent. Either the hardware is going to die first, or the the application will be popped because it's from a security vulnerability, and then they'll be forced to change then because they have to either pay up the money for data loss or time loss.
Well, we'll see. I'm just saying we'll see. But anyway, that's all I have to say on that. Go ahead.
No, it happens all the time. A lot of your old banks who did not make the transition are paying for it now. And so the advancement of cloud computing and their unwillingness to adopt it has set them back years in competing with these neo banks, these new banking companies who operate straight from the cloud. PayPal was one of the first fintechs out there. That's why PayPal is so successful. Multi-billion-dollar company doesn't have any offices anywhere.
I overall agree with you, but some of these big brick and mortar bad boys, the Bank of Americas and so forth, these they're still sitting with that. So Mike, you'll never get any disagreement with me on that or any argument. It's just, can you get these banks and stuff to move at a faster rate? And it seems like there's resistance, and that's kind of what you're dealing with, and from the tech side, not a lot of people are pushing to get some of the stuff out of there. Old COBOL, CICS, DB2, and all this shit still around. I mean, think about it. It's crazy.
Yeah, you see a lot of people that don't know the language. They know Python, but they don't know that.
That's right.
So what are they going to do? They're stuck on it.
And you got these you got these Russians who just literally have I call them the Russian mafia, and they that's what I call them, but they're not literally, but they are out there just handling this stuff. They're in control of that. They are in control of that.
There's a lot of money to be made from digital transformation now. Especially on the continent of Africa. When I was over there, a lot of African central banks and private bank companies still stuck on legacy stuff from the 80s, from the 90s. Can't get off of it. No one there knows what to do with it. So if you want to go into if you want to be an IT entrepreneur and be a renegade and kind of get into digital transformation, there's a lot of money to be made over there transforming these old banks and institutions off of this legacy stuff. Still running Solaris systems over there, still running old HP Unix stuff over there. They can't get off of it because no one knows how to get off of it.
Still running Sun Solaris? Oh shit.
Oh yeah.
SCO and all that? Oh my gosh.
Well, the colonialists left a lot of systems behind, man. So they never, they weren't going to destroy it. They left a lot of systems behind. There was nothing they can do about it.
Yeah. That stuff is 90s, man. 90s stuff, man. Wow, it's going back a long ways. All right.
Yeah. Now's a perfect opportunity to learn blockchain and learn all this type of stuff and really become that IT consultant that is necessary in this growing market. Digital transformation is the key now. The governments in the United States don't really adopt things like zero saying. They can really slow to turn things around. You know, they spent a lot of money on hammers and toilet seats, but they didn't spend any money on on migrating off of these platforms. And so that's where we are right now. During the pandemic, a lot of these institutions don't have what it takes to keep up. They're stuck. The real question is, what are you going to do about it from an IT professional standpoint? You can stand by and watch this stuff decay in your face, or you can be a part of the solution and really drive this stuff forward. I'm a part of the digital transformation piece myself in cybersecurity. I work on integration, orchestration, automation. So I can tell you a thing or two. Yeah, Zero was saying some very good stuff.
No, I consult part-time and try to get some of these companies to, you know, do something about their infrastructure, because once they do stuff about the infrastructure, it helps everybody.
Mm-hmm.
So I'm not even gonna get started on banks. I'm just gonna leave that alone. I've only seen a few banks that actually keep up, and U.S. Bank is one of them, and Wells Fargo. But other than that, man, I walk into banks all the time, and they're horror shows. As far as what you're talking about, what would help, and I try to do this on my channel. I got to put more videos out going over this employment stuff, but Black people on average have to be at least 3 times better than their counterparts. And I know this because I actually went through it myself. Every job I ever had, I had to take an IQ test to get it because they use that as a barrier. Every Black person I've ever seen in the industry always knows more than just one area. They always have one area of expertise. They're almost like polymaths. So like, I couldn't just be a network engineer. I had to know, I know how to code, and I know several different coding languages, and I have to be proficient at coding. Just like the Black coders that I know in the industry, they actually have to know network infrastructure and servers. They can't just know how to code. They have to know more than that. So I guess my solution to that problem is get more Black people in the industry,
Yeah.
which is pretty difficult.
Yeah, Nagon could tell you there's 1 million recs on the table across this country, and a lot of them are unfulfilled. And we can't get enough Black people to actually get into this market for whatever reason.
Yeah, and you have a lot of people saying, "Oh, well, you know, they got the H-1Bs and all that, you know, and you know, you have 3 million H-1Bs here. Yeah, they got a lot of, because there are a lot of IT jobs, and you have a lot of these H-1Bs and so forth that are already on them. But you still have, Mike knows that you have 1 million recs on the table, and it's been this way for years, and it's going to stay this way, unless, you know, we produce more IT professionals to really come out here and cover a lot. And the game is and it's moving so fast that it's not even funny for just new technology. And then we can't even talk about all the stuff that's going on with respect to where companies have to upgrade and migrate and do new stuff just to bring themselves into the 21st century. And
Right.
all you know, those are huge, you know, infrastructure issues as well. So IT and collaborative computing here in the United States is so much is behind the times. You already know what's going on. You mentioned the banks. You're not even talking about the large insurance companies you're not even talking about them that have just, oh man, horror shows that you'll see. Northwestern Insurance. I mean, just take a look at a lot of these companies. These guys are freaking archaic. They're ancient, and they, you know, and I'm putting the money there. And the migration game that's huge. You know, because, you know, I was thinking just myself. I was able to start a migration company, just do migrations. But then again, it's just hard to move half of these guys to do them because they don't want to spend 2 or 3 or 4 million you might need to move from one, from one platform.
But they don't even have to spend all of that. From my experience, like I've been in the game like 20 some years, and
well, if you go from SAP or something else like that, some of that stuff is pretty expensive. But anyway, go ahead. Sorry.
No, you're right about that. So like So what I've seen is these cycles, right? So you got these consulting companies that'll come in and replace your in-house expert or your employee. Your in-house expert, you hired that person to actually do what you need to do, but then you have a contractor come in and do that person's job because that's how companies have always really done business with contractors. Contractors just get their way in there, you know, they'll ease their way in to get business through something else, like consulting on something completely different. You know, they might be consulting on like some executive level business intelligence stuff, but then they weasel their way into the IT side through that avenue. And so they'll weasel their way in, replace everybody, and then 5 years later, the company realizes that they're overpaying for the IT, and then they start hiring employees again. This is why I say, like, you get Black people in there because, like I said, because we have to do more than one thing. Because because my counterparts, the white guys, they'll know one thing, just one thing, and it actually kind of costs the company money because they can't solve high level problems because they're limited in scope. Like, whereas me, if I'm an infrastructure engineer and I know more than one thing, it'll be like, I can take a problem and solve it no matter what area it's in, because first of all, I have the permission to do so. And second of all, I have the skill set ranging from coding to administration to solve the problem. You know what I mean? I'm not limited to just like a coding problem. Like if let's just say if it's a network problem and I'm a coder, I'm never going to figure it out. But if in my position, if it's a network problem and let's just say it's a network problem, but it's related to, I don't know, a query that's pulling too much data at one time, I can figure that out because I'm on both ends. Whereas my white counterparts can't do that. So in order to solve that problem, they'd have to hire a contractor to come in and do it. So this is why I'm saying, as far as like getting Black people in there, because they will have more skill because they have to. They don't have a choice. So, I mean, that's where I'm at with it. Other than the contractors, because contractors are, they're taking all the racks y'all was talking about off the table because companies are overpaying them. Whereas if we can get the contractors out of the way and hire people with multiple skills, there's enough money for everybody. So, I mean, that's just the way I'm looking at it.
Yeah, to an extent that is true. The thing is, contractors don't get vacation. They don't get all the benefits. So the company's actually saving money.
Right.
They are, because they don't have to give them full benefits packages and so forth.
Well, that's true. That's true. But they do charge a ton of money to do stuff.
I mean, if they charge 110 an hour, you know, but if you take, okay, let's say they charge 110 bucks an hour, 115 or so. All right. Still, with that employee who's making, say, 85 or 90, then you start putting into his 401k, his overall health insurance plan, and everything else like that you have to cover. It comes out to be more. So, you know, they cover. So it becomes more expensive to maintain that guy. The bottom line, very simply, is what I've seen here, and what's the real problem is here, and I see it on a ground level. I've been in this business since 99, 2000. Look, we don't have enough good technologists. We don't have enough good American homebred people. We're not putting out enough of them. There're not enough of us in the game, period. They're not enough of us. White boys, Blacks, and so forth. Latinos, we're not enough. There's not enough of us. That's the reality. We're not getting into it. We're not there. And that's where we're at. A lot of these white guys coming in, I'm a technology guy. A lot of them fucking suck. They suck. You will call it out as well. They suck. They have weak skills. They're soft like a Twinkie filling up in this piece. They're not out here heavy duty. The few that are out there are doing very well. All right. The Black guys that are out here that I know, and every single Black person I've had who's had a very high technical level of skill, I've gotten every single one of them hired. Every single one of them. Not one of them is sitting on the beach. All right. Like some other people saying, no, you're not gonna get the job. That's not what I've experienced. But I don't see enough top-notch level Black people out here who are developers, who are sysadmins, or so forth. I don't see many of them. Just don't. The ones who out here who are stacked up to the gills, they're working. So just not seeing it. We're not producing enough, and that's our problem. That's our problem.
Yeah, the problem with that is that we don't cultivate IT people at all in our communities, right? We don't. I mean, it's one thing for a guy to, be at Geek Squad, but we don't cultivate IT as a career path. It's not really cultivated. It's people promise them, oh, if you work in cybersecurity, you'll make, $200,000. You'll be the next Edward Snowden. In reality, they don't even understand the base components or the core structure of technology to really be a cybersecurity person. And so we're selling hopes and fantasies, but we don't really drive IT culture. Like, Zero came from the ground up, trying to get in. He used to play ball. I used to play ball. Man, we put the ball down, picked up the laptops, and got in. That's how we got in. But there's a lot of people who don't really have an understanding of what they want to get themselves into. And that's why we do the Black Tech Talks on Saturdays, to really try to drive people in that direction. We have several people who have come through the Black Brain Trust and have gotten jobs in IT at a very high level. Some Black people get told, oh, go to this boot camp. They go to this boot camp, and the boot camp is moving so fast, they have no idea what's going on. They get lost in the sauce, and now, they're way behind. And instead of just taking the L, they stay the whole way and waste all their money, and then they don't get a job, and now they're disappointed. Now, had they had a mentor to begin with, they would have had better outcome at some point. But we just don't cultivate enough IT people at all in our community. So.
Oh yeah, I agree with mentorship wholeheartedly. I actually go back to my old school. I go back to my old college, and any Black kids in the well, I don't limit it, but I try to make sure that when there's Black kids in the class, that they come after school, and actually stay and study, because I'll teach them how real world jobs works. I mean, I'll log into the VPN at my job and show them how a network infrastructure looks in real life versus what they're learning in school, because they're like really. I'm sorry. Go ahead.
You see what you're talking. You see what you're talking about. How you're breaking this thing down as to how you got to mentor and train. You see, we need to change how our educational system right now is not sufficient. That's a big part of the problem. We have to change that, and the kind of thing you're talking about, which we deal with man, especially they got Silicon Harlem and all the stuff going on now. In some of these school systems, you have to change how we're getting educated. Yeah. And I think, and that's the bottom line. Your mentorship piece you're talking about, and then getting people on top of understanding what we have to prepare for the next wave of jobs that are coming down. We are not training our people for this. They are. Yeah. They're pitifully untrained. And I'm going to say this, not only for us, because it's terrible with us, but for the larger society as well. So we're going to have to make some fundamental changes there, and our school systems are going to have to really look at this, because we are not preparing these kids for what's out there today. They're not prepared. Yeah. And the millennials, they showed you, the millennials came out of school. Most of them did not go into tech. Most of them, got degrees in fine arts and all that, and that's why they're working over in Starbucks, man, as barristers and stuff. They
so nothing with Vin Baker.
Exactly. They did not prepare. They were not prepared, and they didn't go for the right kinds of education, the kind of education that they needed for what's needed out here. And
you compound that with a pandemic like this.
Forget about it.
And they're highly finished. So
I won't laugh, but boy, you're right about that.
No, but Gabe A in the chat says consultants who work for consulting firms get all the benefits of a full-time permanent employee. Yeah, that's true if you work for a consulting firm.
You work for a consulting firm, but if you're a consultant.
Yeah, if you're just a consultant, W-2 with no benefits, then that's what it is. You get no benefits. And so,
or you going corp to corp, you have your own corp, that you're doing, and it's
Yeah.
totally different game.
I've typically seen consulting firms come in and really are the ones that push employees out of the way.
yeah,
Yeah.
yeah. And if you're, W-2, W-4, you're at will, bro. They can let you go tomorrow. You don't even
Yeah, for no reason.
Yeah. But you're at will, so that's how they feel. And well, your breath stink today. You finish.
Oh yeah. I told this story before. I had a young brother, had his hair locked and everything else. Probably shouldn't have, but he was doing some decommissions. He was walking with some laptops. They were already going to be disposed of. He dropped one of them. Some employees saw that, reported to the manager, and they fired him for it, even though these laptops are going to be decommissioned. But that's how they think. That's how they think, man. So you can be, you can be a 86th, when you're a contractor like that, and you have no recourse.
So I guess just to finish what I was saying. So when I'm mentoring, I really want to show them what a network infrastructure looks like in real life, because when you're in school, you're in a perfect world scenario. Like everything you do, and even when they present you with a problem and say solve this, it's a controlled problem. It's always something that it's easily solvable every single time. It's the same answer every single time. Whereas in real life, when something happens, the answer might be different, or you might have to troubleshoot in a different way. You might have different tools and whatnot. So when I'm mentoring, I'm always really logging into the network and showing them what the tools that I use and how I troubleshoot. Or I actually even have virtual machines saved. Before I do a problem, I'll take a snapshot of a virtual machine when it's in a really bad state. And then when I resolve the problem, I'll be able to repeat that if I'm showing somebody what I did. So that's one thing you can do as well. So I basically just try to get them to see that in real life, they're going to come across stuff that's not going to be, like in a controlled classroom. But at the same time, what they're learning in class is completely applicable, because all of this stuff is really 1, 2, 3 solution type shit, because you just have to apply what you're learning in school and strip out jargon. That's probably the biggest obstacle for a lot of, especially Black people, to get into IT, is the jargon. They'll use jargon like threshold storm, which means nothing to someone who's not in IT or hasn't come across it. And it's a made up jargon term that EMC had for when the SAN went crazy and disconnected from fiber channel. So they just made up a term for it. So stuff like that, and that'll keep people from getting involved in it, because the terminology is so foreign and obtuse that it makes people think like, well, I don't have time for that shit. Just like with like medical terms and stuff. It's all jargon, but it's jargon for the field. I try to strip that out and make things really simple, or have them put ideas in their own words and own thoughts. This way, like when they run across problems and stuff like that, they can look at it. And if someone gives them a jargon term, they can say, let me look at it. And then after they look at it, they can translate in their own words and say, okay, here's what the problem is. I get what you're saying, but here's what the problem is. I can solve it now. So that's what I really try to do.
You're not a member of NISB, are you, Joe?
A member of what?
NISB.
I don't know what that is.
National Society of Black Engineers.
No.
Oh man, you should have already been a member, brother.
All right, let me check that out. I'm gonna go to the page.
Get your son in there too, man. Real talk. Get your son in there. It's free for your son. I mean, but you're gonna pay. But you should definitely be a contributor.
Okay. Yeah, I see it. Okay, I'm gonna create an account in here.
Yeah. Gabe A says there's a lot of expertise in consulting firms, and we get in there and solve problems. It also gives you great exposure to C-level executives. Working for organizations internally limits many people's careers.
Well, that's true. Well, yeah, that's true. In my position, no, but generally speaking, yeah, he's right.
Yeah, but Game A is speaking from like 2.0 logic though. But that's his opinion. It all depends. If I got a job to work at, if I got an opportunity to work at Google,
Like,
I don't know if I would I don't know if I would say that that's less maneuverability in a place like Google as opposed to being a at-will contractor or something like that. I don't know. I just think that if Google called me tomorrow morning or emailed me tomorrow morning and said, hey, we got this role open, you need to start on Monday. Sorry, I'm out of here. No loyalty to this company because they're not going to talk to me. I can tell you that much.
Yeah. Google is ridiculous in both compensation, perks, and everything else. So.
Oh man, it's amazing some of the stuff I see them do. Cause we have the I'm only about 10 minutes away from their regional office here, man. I've been up there many times before, and it's amazing some of the stuff they do up in there. It's like a wonderland or something. But yeah, let me close this out, man. Thank you all for joining us. Please hit the like button if not already done so. Share the video if possible. Hit that notification bell so you get all the updates from the Black Brain Trust, including those posted on the community tab. Document and description beneath the video for you to reference. Shalom, everyone.